Hey, what's up, Blue Team? Welcome back to episode 3 of my multi-part series on data integrity. In the first episode, we discussed why protecting your data is important and some philosophical aspects of how the data that you keep on your computer is in some ways a part of who you are. And in the second episode, we talked about different kinds of storage media that can be used to store your data, along with the benefits and the drawbacks of each. So now that we've covered all of that basic information, we can switch gears and actually talk about threat modeling, risk, and identifying different threats to our data. So before we can have any kind of conversation on what the best practices are for keeping your data safe, we first need to think about what we're trying to protect our data from. So this might sound a little stupid and patronizing, but it's important that we keep our terminology straight. In case you're new to formal discussions about security, I thought that it would be good to start out with laying out some vocabulary. So let's start off by discussing what a threat is. A threat is an event or condition that has potential for causing asset loss and the undesirable consequences or impact from such loss. So basically, a threat is any possible bad thing that you don't want to happen. Now, that definition might seem super obvious and common sense, and you might be thinking to yourself, why do I even need to spell out a definition like that so formally? But I'd like to point you to a specific aspect of that definition that you might find interesting. So if you'll notice, there was no mention of any malicious actor in that definition. So a threat doesn't necessarily even have to come from a malicious source. And it's really important that we remember that when we're discussing what a threat is, because there are a lot of different ways that we can lose our data. So let's talk about how we think about threats, or in the security industry, what we call threat modeling. Threat modeling is basically just sitting down, making a list of all of the possible threats that could impact you, figuring out which threats pose the most risk to you, which threats are the most likely to happen, and deciding which threats you want to prioritize versus which ones you don't really care about as much because you don't think that they're as likely to happen. Threat modeling is super important because it helps you determine what you're actually trying to protect yourself from. Security doesn't have much of a purpose unless you define what it's supposed to be doing for you. So threat modeling is important because it helps you focus your security efforts in a meaningful way. Basically, it allows you to determine what's actually important and actually prioritize it. So now that we've got all of those definitions out of the way, let's talk about some actual threats to our data that we can put into our threat models. So you know how I was saying that different kinds of threats may or may not have malicious actors behind them? Well, that's actually a really important distinction. So we can first break out our threat model by distinguishing between operational threats and security threats. So let's talk about operational threats first, since there's a lot to talk about here, honestly, and potentially even more to talk about than actual security threats. So operational threats are specifically events that cause you to lose data, but are not the result of anyone doing anything malicious. The primary operational threats that your data faces are hardware failure, bit rot and data corruption, user error, natural disasters, things being removed from the internet, and deprecation. So that's a pretty long list to go through, and let's go through that one by one. So the first and most obvious is hardware failure. Hardware failure is pretty self-explanatory. So when your hard drive breaks randomly, your phone breaks or something like that, you lose all the data on it. Pretty obvious, right? Well, sometimes, but other times it can get more complicated than that. Even though your hard drive, it might be nice enough to die all at once so that you know that all your data is gone, it can get way nastier. And that's where we get into our second threat, which is bit rot and data corruption. Sometimes when you're copying files from one place to another, parts of the files that you're transferring don't copy correctly and can render your whole file unusable. We call that data corruption. There's a lot of ways that data corruption can happen, but the most common cause is when you have a storage device that starts going bad and copying data improperly. In some cases, your operating system might be smart enough to notice that data is being copied incorrectly and alert you of the issue, but usually it won't. The nasty thing about data corruption is that if a device starts dying, this can happen slowly and silently over the course of months before you notice anything. And by the time you've realized what's happening and run into corrupted files, you've already overwritten all of your old backups with corrupted data. So when you try to restore from your backup, those are corrupted too. Not a good day. I've had that happen. It sucks. Don't do that. I've been talking a lot about things like hardware errors causing data corruption, drives going bad and things like that, but that's not actually the only source of data corruption. The universe hates your data, and it'll do a lot to destroy it. Things like cosmic bit flips do happen and will result in your data being corrupted just over time because that's what happens. While data corruption's a really big issue, there are some pretty good ways to deal with it. It is pretty complicated to get into that though, so I'm going to leave that for next week's video. So hold that thought for now. Let's move on to talking about the next threat. The next operational threat I wanted to talk about is a scary one. In many ways, I think it might be one of the most scary threats of them all on this list. And that terrifying threat that I'm talking about is none other than ourselves. We're all humans here, meaning that each and every one of us is prone to doing some really, really dumb shit every once in a while. I'll be the first to shamefully admit that I've mistyped a format command before, and next thing you know, I accidentally deleted an entire server worth of my data. Not my greatest moment, but it happened, right? And it can happen to any one of us. So when we think about our threat model, it's really important to factor ourselves in. We have to take precautions to make sure that whatever we do, whatever mistakes that we make with our data, that they're recoverable and that we don't lose everything just because we do something stupid. Anyway, let's move on. Another one that you might not really be thinking about all the time just because it doesn't happen to a lot of people, and it's really easy to say, that'll never happen to me until it does. That threat is natural disasters. This one's pretty self-explanatory, but if your house burns down or floods or whatever, there goes all the data that was there. And it happens. And it really sucks. So don't assume that you're immune, and realize that if you have all of your data just in your house, and that's the only place you have it, if something happens there, you're not going to have a good day in more ways than just your house burning down. Let's leave it at that. Moving on, the next two operational threats that we're going to talk about are a little bit more esoteric, but they're really important to keep in mind as a source of data loss. So let's first talk about stuff getting removed from the internet. When's the last time that you went to listen to a song that you like or watch a video on YouTube that you once saw only to find that it's been copyright striked or deleted by the person who posted it or something like that? I'm willing to bet that it's happened to you before, and it's one of the worst feelings ever. The point that I want to make is that the internet is a surprisingly ephemeral place, and things get taken down all the time. If you like a piece of content, save the video, take a screenshot of the page, download the song, do whatever you got to do to make a local copy. If you like something, you need to save it, because chances are someone else will take it down. And it's not always for reasons like copyright or takedowns or malicious activity or anything like that. Sometimes someone just runs out of hosting money and their website goes down because they can't pay for it anymore. And especially for small projects and things like that, and the smaller websites that you browse, those things won't last forever. I can't say this enough. If you like something online, save it or you will lose it. It's just going to happen to you, and it's going to suck when it does. So just save it. Anyway, let's move on and talk about the next operational risk. So now let's talk about deprecation, which is another really important risk that's really easy to overlook. Your computer and the files that you have on it don't exist in a vacuum. The hardware and the software that you use today isn't the same as what you used 10 years ago. Things change over time, and not everything is backward compatible. Sometimes the software you need to open a specific kind of file, it's just going to stop working on the newest version of your operating system. Or maybe you just don't have a VCR anymore to be able to play back the video cassette recordings taken by your grandparents. The point that I'm making here is that once a file or device becomes obsolete to the point of being unreadable, your data may as well be as lost because you can't access it. None of us can see the future, but it's so important that you do your best to try and future-proof any data that you have so that it'll still be accessible decades from now. Try to use technologies that lots of people already use and update your old files over time to make sure that they're using newer formats when they start to go obsolete. You don't want to end up in that position where you have, an old hard drive full of some ancient files from some program that no one can run anymore, and you just can't use those things anymore because you never took the time to update them to newer versions. You guys remember old Flash games and Flash animations? Yeah, I do too. That stuff was pretty cool, but chances are you might not even have a device that can play those anymore, which in a way kind of sucks, but that's just how the world works. So that pretty much covers it for operational threats. The universe is a pretty harsh place for your data, and a lot of things can go wrong. So let's move on and let's talk about some security threats. Security threats, these can be really terrifying. A security threat is any threat that's caused by a malicious actor actively trying to access your devices and data. These can be broken down into two subcategories: software security threats and physical security threats. Software security threats are things like hackers, viruses, all of that shit. The scariest and most obvious threat when it comes to software security is ransomware. This is the big one. Ransomware is malicious software that, once installed, actively seeks out your files in order to intentionally corrupt them and try to extort you for money in order to get your files back. I say corrupt because even though the ransomware will say that they encrypted your files and if you give them money, they'll get you your data back, most of the time they won't, even if you pay them. So if you ever get hit by one of these, don't ever pay the ransom. Just assume that all the data that they stole is gone. But I digress. My point is that there are forces out there that want to get access to your computer, that want to get access to your data, and they want to do bad things to it that you don't want to happen. So you need to protect yourself against those things. Ransomware is super scary because it can happen to literally anyone, no matter how smart you are, how secure you think you are. And once it's on your system, it'll often intelligently try to look for your files wherever it can find them. This means that it'll hit not only your local machine's hard drives, but any sort of readable network shares, as well as any signed-on cloud storage that you might have. Realistically, if your computer has access to something, ransomware that's installed on it will look for it. And you might be thinking to yourself, well, I'm not going to get hit by ransomware. I'm smart. I don't do anything stupid. I don't download random stuff off the internet. But there's other ways that it can get on your system. One example is through supply chain compromises. You have a lot of different software installed on your computer from a lot of different software providers. If just one of those software providers gets their systems hacked by a malicious actor, the attacker could potentially utilize their access to that provider's systems to push out a malicious update through the trusted installer built into the application that you're using. When a supply chain attack happens to a software provider for a software that you trust, there is literally nothing that you could have done beforehand to have prevented it. All you can talk about at that point is impact. Once you got an attacker that's pushing out malicious software through the updater on a trusted piece of software, that attacker can push out whatever they want to your computer, whether that be, ransomware, adware, tracking, really anything. Malicious updates from supply chain compromises put you in a position where the only thing you can really do as a response is pray to whatever God you do or don't believe in, that whatever backups you may have had for any data that you lose as a result of the incident are enough to actually restore what you need. Anyway, my point is that ransomware should be on your threat model. No matter how smart you are, no matter how secure you are, it can happen to you, just like any other threat that's on this list. The other kind of security threat that we need to worry about are the physical security threats. A little bit of a content warning on the next bit because I'm going to be talking about some hypothetical scenarios of violence. Physical security threats include stuff like getting robbed and having your devices taken from you. This could mean, getting mugged on the street or having your house broken into and computer equipment stolen. Physical security threats can also include your devices being physically accessed and tampered with without your consent. This can include stuff like an abusive partner or a family member accessing your device in your home while you're not present. There's also things like government actors that can confiscate your devices and tamper with them and use that access to access other kinds of data that were accessible by that device. One of the most interesting cases of a physical security breach used to access someone's protected data that I can think of off the top of my head is the way that the FBI took down the founder of the Silk Road. I'm going to leave a link in the description below for an article about this, but just to kind of summarize what happened was this guy went to a public library all the time to do what he did. So one day they followed him to the library with 3 agents undercover. 2 of the agents walked in behind him, and after he got situated, seated at a desk, and was typing away, the agents walked up behind him and pretended to get into a fight with each other so that they could temporarily distract him. While he was distracted for just like 2 seconds, the 3rd agent came up, snatched the laptop while it was completely unlocked, and had full access to all of his data, unencrypted, without even having to force him to unlock his laptop for them. Pretty clever, right? Well, I don't think that it's reasonable for most of us to be worrying about the FBI concocting some complex plot to force us to unlock our data or get access to our data while it's not protected, I still think it's reasonable to think about the fact that someone might be able to gain access to your device while it's in an unlocked state, and you might want to think about what they have access to if they can do that. What if someone mugs you for your wallet and phone, holds up a knife to you and says, "Hey, give me your phone passcode"? You're probably going to give it to them. And you should, by the way. Your life is more important than your technology. But what do they have access to if they get that passcode from you? What can they do on your phone? What does it have access to? Does it have access to all of your cloud storage that can be completely read by whoever just took your phone from you? Might want to think about that, right? It can happen. Okay, well, that's basically all of the threats that I wanted to discuss with you today. I know that I was pretty general about all of this, and I could probably do a whole deep dive video on the specifics of any one of these threats, but really the point of this video was to get you thinking about threat modeling in general. I want you to think about making a list of all of the things that can happen to your data. Write them all down, think about how likely they are to happen, and what are you going to do to prevent them from happening, right? You might have noticed that even though in this video we talked a lot about what the threats to your data are, we didn't actually talk that much about what you might want to do about all of these various threats. And that's because, just like in any topic in security, there's really just no good way to come up with a set of best practices without first scoping out your threat model and figuring out what the threats are, assign a risk to them. Now that we've discussed why protecting your data is important, how to store your data, and what you need to protect your data from, next week we can finally have a conversation about what I think are the best practices when it comes to maintaining data integrity and making sure that you don't actually lose data. I hope that you found this video useful. Thanks. Bye.